Hi! Welcome back once again, grade 5. At this time, we will be using our skills in divisibility rules in solving problems, routine and non-routine, which is still in week 2 of our competencies. And this time, we will be using your module number 4. Get ready! Before we formally start our lesson in solving routine and non-routine problems involving factors, multiples, and divisibility rules for 2, 3, 4, 5, 6, 8, 9, 10, 11, and 12, ito ang mahiwagang whiteboard to show you the first activity that you need to do. This is a sort of review from what we have learned in our previous lessons. So get your notebook and try this one. Are you done with our first activity? Get ready, for I am about to reveal now what's the complete answer for this activity. The answers are the following. For 2, the only number that is divisible by 2 here is number 1, but the rest, they are not divisible by 2 because that's the only even numbers. Then for 5, I think this is divisible by 5. This one is divisible by 5, divisible by 5. The other two are not divisible by 5. Let's go to 10. Ends with 0, so all the numbers are not divisible by 10. Let's now proceed to number 3. Let's check if all these numbers are divisible by 3. So all you have to do is get the sum of the digits. So this is 5, 9, 10, 18. 18 that is divisible by 3. And 18 is also divisible by 9. So you also check this one. Okay, this time you try number 2. This number 2 is, this is 10, 18, 19. So that is not divisible by 3 and not also divisible by 9. For number 3 here, we have 10, 15, 18. So that is divisible by 3. And at the same time, 18 is also divisible by 9. For number 4, that is equal to 10, 11, 15, 16, 17, 18. So that's divisible by 3. This one is also divisible by 9 because that's 18. Here that is 5, 10, 12, 13, 14. 14 is not divisible by 3, and of course that's not also divisible by 9. Let us now proceed to the column of 6. Of course, because this number is divisible by both 2 and 3, so that's divisible by 6. This is not divisible by 6. This one is not also divisible by 6. It's supposed to be double check. 2 and 3 not divisible by 6. This one is not divisible by 6. And this time, let's proceed to the column of 4. We will have to look at the last 2 digits. 14 is not divisible by 4. 35 is not divisible by 4 either. 85 is not divisible by 4. 81 is not divisible by 4. 255 is not divisible by 4. For the column of 8 this time, we have to look at the last 3 digits. So 814, 800 is divisible by 8, but 14 is not divisible by 8, so that's not divisible by 8. 235. Kung nag-240 sa tani, then that's divisible by 8. So 235 is not divisible by 8. 285. 285 is not divisible by 8. 281, that's not divisible by 8 also. And 255 is not divisible by 8 also. And now let's proceed to 12. Before we'll proceed to 11, let us first answer 12. It would be easier for us to tell if a number is divisible by 12 because we already have the column for 3 and the column for 4. That's supposed to be divisible by both 3 and 4. So if there's a double check, check for 3 and check for 4, that's automatically divisible by 12. This one is not divisible by 12 because one check only. This one not divisible by 12, not divisible by 12, not divisible by 12, not divisible by 12. This time, let's try the rules for 11. So let's try to get the sum of the alternating digits, then their difference. So this one and this one, they are grouped, so that is equal to 6. This one and this one, they should be grouped, so that is equal to 12. Now 12 minus 6, the answer is 6. 6 is not a multiple of 11, so X for this one. Here, this one, and this one. The three of them should belong to one group. So 8 plus 2 plus 5, that is equal to 15. These are other numbers in the same group. So that is 4. So if you will subtract 15 minus the 4 here, that's 11. That's a multiple of 11. So check here. For number 3, this one and this one, the same group, so that is equal to 11. This one and this one, the same group, so that is equal to 7. So if you will get their difference, the answer is 4, not divisible. Let's proceed to number 4. 3, 2, and 1. The sum of these three numbers is equal to 6. Here, that's 4 and 8, that is equal to 12. If you will subtract, the answer is 6. So I think that's not divisible. And finally, here, that's one group, and this one, and that one. So 5 plus 2 plus 1, that is equal to 8. Now, we have here 1, and we have here 5, so that is 6. If you will subtract, the answer is 2, not divisible by 11. It seems that you already mastered your divisibility rules. At this time, let us now proceed to our lesson. I will be showing you a problem. Study the problem and answer it. The problem that was shown to you is example of the problems that you often see in your math class. And of course, there are two types of problems that we encounter in our math class. The first one is the routine problem and the other one is the non-routine problem. What is the difference between the routine and the non-routine problem? Routine problems are the problems which you often encounter, and these are useful for your daily living. In our math class, these problems are easy to solve. The fact that the given are already present, and of course the operation to be used can be easily identified or detected. Usually, these are the problems that could be easily equated or could be easily written in mathematical equation. However, non-routine problems are the problems which are a bit challenging, wherein you really have to think first, to think critically what's the best solution for a particular problem. Sometimes this could not be easily written in a mathematical equation, so the tendency is you look for other heuristics in order to solve the problem. Okay, non-routine problems are mostly concerned with developing the mathematical reasoning and fostering an understanding that mathematics is a creative endeavor. That's why we suggest some heuristics such as listing methods, such as drawing or making a block model, such as systematic listing, thinking outside the box, and a lot more. There are still a lot of heuristics that could be used for this particular problem. One of the tests that I am using always in routine and non-routine problem is the Polya's 4 steps in solving the problem. If there is a certain point in the steps of Polya which I could not easily use for me to solve the problem, the tendency is, especially the planning stage, the tendency is I would think that the problem needs critical thinking and the problem needs more heuristics in order to solve the problem. I need to involve other heuristics. So the tendency is the problem might be a non-routine problem. So this time, I will be giving you some of the problems that we need to do. Let's try also to use the Polia's 4 steps in solving the problem. So get ready, and I will be showing you steps on how to solve the problem. We will use the Polia's 4-step plan in order for us to solve the previous problem that I gave you. So this time, let us first familiarize ourselves of the Polia's 4-step plan. Polia would suggest that there are 4 steps that you need to consider in solving math problems. The first one is to understand or read and understand. You already read the problem, so let us understand. So as we understand, we need to know what is asked in that particular problem. Next, what are the given in that particular problem. Next step in number 2 is plan. So you have to first identify what operation to be used in that particular problem. And the next thing, if you could write it in mathematical equation, or you could you could write the number sentence for the problem. So what is the number sentence? Of course, the step number 3 is to carry out the problem, or that's the time that you will have to solve the problem. And finally, you have to check your answer. My pupils tend to forget the 4-step plan of Polia, so sometimes I introduce to them some styles in memorizing or remembering the steps by acrostics or acronym. For example, what is asked, we will use A. What are the given? G. What operation to use is O. Number sentence is N. You need to solve it, that's S. And of course, you check your answer, so that's A. So I always remind them to, if you forget Polia's 4-step of problem, in order for you to check all the details of the problem, you need to remember agonsa. And this agonsa is about what is asked, given, operation to use, number sentence. That's the time that you will have to solve, and you have to check your answer. So this time also, let us check the problem once again, and let us solve, or let us complete the steps of Polia in order for us to arrive with the answer. In our problem, you are asked there for the common number of trees in each row. That's it. And now, the given are 50 seedlings for boys and 50 seedlings for girls. For the operation to be used and the number sentence, we could not apply it for now, so the best thing that we have to do is to plan how do we solve the problem, because you are only asked to get the common number of trees in each row. So we will just only get the common factors. So technically, the operations later will be, this is supposed to be common factors. The operations later will be used in getting the common factors, and the number sentence, I think this time this is not applicable. Are you now ready to solve? So if you are ready to solve now, I will be showing you different ways on how to solve this problem. Here are some of the ways that you need to consider in solving this problem. Method number 1 is by using the factor tree. Because the given are 50 and 30, you have to get the factors of 50 and 30 to get their common factors. So one of the methods that we will be using is using the factor tree. It simply means that 50 and 30 will be divided into other 2 factors. For example, obviously, this is divisible by 10, so that is 5 times 10. And now, because 5 is already a prime number, so we could not split that one anymore, aside from 1 times 5. However, 10 here could still be further divided into 5 times 2. 5 here is already a prime number, and 2 is also a prime number. So the prime factorization for 50 is equal to 2 times 5 times 5 if arranged in increasing order. The same thing that you will have to do for 30? 30, obviously, that's 3 times 10. 3 is already a prime, and 10 could still be split into 5 times 2. This is a prime, and this is also a prime. What method did we use here is factor tree. That's why it looks like a tree or a Christmas tree. Okay, so for 30, that is equal to 2 times 3 times 5. So this is 25 times 2 is equal to 50. 5 times 2, that is 10 times 3, that's 30. After that one, all you have to do is to get their common factor. So the common factor, they are common with 2, they are common with 5. So therefore, the common factors of these numbers are 2 and 5, or we could also have 10, because 2 times 5 is equal to 10. So therefore, their common factors are 2, 5, and 10 using the factor tree. We are already done with the first method, which is the factor tree method. This time, we will be using the listing method. When we say listing method, we have to list down all the factors of 50 and the factors of 30. Then after that one, you have to get their common factors. So for the factors of 50, those are 1 times 50, 2 times 25, and 5 times 10. So those are the factors of 50. For 30, the factors of 30 is 1 times 30, next is 2 times 15, next is 3 times 10, next we have 5 times 6. So those are the factors of 30. After that one, that you already have the factors of 50 and the 30, the next thing that you have to do is to get their common factors. So they are common with 1, they are common with 2, they are common with 5, they are common with 10. Now, you might notice that the common factors, or CF, common factors, CF stands for common factors. Here are 1, 2, 5, and 10. However, in this case, we only have 2, 5, and 10. Because 1 is a factor of every number, that's why we could still include 1 as our factor. Another method that you could also use in solving this kind of problem is by table method. So all you have to do is you will make a table just like what we did in the divisibility rules a while ago. Then you have to check if they are divisible or not. For example, 50, is that divisible by 2? Yes. Is that divisible by 3? Yes. So check for 2. 50, is that divisible by 5? Yes. Is that divisible by 5? 30 is divisible by 5? Yes. So you try it by 2, by 3, by 4, by 5, by 6, by 8, by 9, by 10, by 11, by 12. So you will end up that these two numbers are only divisible by 2, by 5, and by 10. Now, all whole numbers are divisible by 1. That's why 1 should still be included as their common factor. After we are done with the fourth step, which is solve, the next thing that you have to do is to check your answer. When we say check your answer, all you have to do is go back. If really 50 divisible by 2, 50 divisible by 5, or 50 is divisible by 10. The same thing that you will have to do with 30. Is it really divisible by 2? Is it really divisible by 5? Is it really divisible by 10? So all you have to do is double check by dividing dividing 50 and 30 to all their common factors. That's how you check your work. If your answers here 2, 5, and 10 could divide evenly 50 and 30, then you are pretty sure that your answer is correct. Which method you are most comfortable with? Are you comfortable with using the factor tree method? Are you comfortable with listing method? Are you comfortable with the table method? Or have you found another method on how to solve this problem? So our final answer for the given problem a while ago is 2, 5, and 10. If there is no more problem or no question with this problem, let us now proceed to the next problem that will really challenge you. Here's our next challenge. Delphine is willing to give a reward to whoever guesses his age this year. His clues state that his age is divisible by 12 and a multiple of 9, and that he is less than 51 years old. How old is Delphine? Pause this video and think for what's the answer of this problem. Let us now solve the problem. According to Polia, the first step that you have to do is know what is asked. Again, that's Gonzo. Know what is asked. What is asked in this problem is the age of Delphine. Age of Delphine now. The age of Delphine this year. So the age of Delphine now. The next thing that you have to do is what are the given? The given is the age is divisible by 12 and at the same time it is a multiple of 9 and less than 50. Okay, we cannot tell now what operation to use and what's the number sentence for this that we usually do in word problems. So this time, let us just plan if what's the best thing to do in order to solve this problem. So to solve this problem, of course, let us first limit our answers. Our answer should fall between less than 51, so that's supposed to be 1 up to 50. So these are the possible answers. His age should be 1 up to 50 only because he should be less than 51. And it's supposed to be divisible by 12. When we say divisible by 12, what are the numbers from 1 to 50 which are divisible by 12? So those are 12, 24, 36, 48. Those are the possible answers. The next thing that we have to do, it should be a multiple of 9. Among the possible answers, which is a multiple of 9? This is not a multiple of 9, not a multiple of 9. Yes, it is not a multiple of 9. Therefore, Delphine is 36 years old. So, the next thing that we have to do is let us check our answer. Question, is 36 divisible by 12? That's correct. 36 divided by 12, the answer is 3. Is 36 a multiple of 9? Let's divide 36 by 9 and the correct answer is 4. Now, is that less than 51? Yes, it is. Therefore, Delphine is 36 years old. At this point, I will be giving you 5 items that you need to answer first before I will give you the solution for the following problems. So, look at the problems and try it by yourself. Here are the problems. Let's now look at the answers for the 5 problems that I gave you. So, in problem number 1, Ruben is arranging 648 tiles fitted in a bathroom. He wants to put the same number of tiles on each row. How many tiles can Ruben put in each row? So remember, in item number 1 for Ruben, he will be putting 648 tiles. And of course, the choices are letter A, 5, letter B, that's 11, letter C, that's 10, and letter D, that's 12. Among all of these numbers, which do you think is 648 divisible? Is it by 5, by 11, by 10, or by 12? Obviously, this is not divisible by 5 and not divisible by 10. So let's try to check if it is divisible by 11. So 8 plus 6, which is equal to 14, minus 4 that is equal to 10, not divisible by 11. But I'm pretty sure then that is divisible by 12. Let's try. 648 divided by 12. So the answer is 5. That's 60. Subtract, that's 48. That's equal to 4. 48, 0. So the correct answer for number 1 is letter D. For item number 2, Teresa is organizing 990 blocks into boxes at the toy store. She needs to put the same number of blocks in each box without any leftover blocks. How many boxes would Teresa use for the blocks? Remember that she has 990 blocks. So this time, let's try to think if to what number is 990 divisible. Okay, for 4, is the last two, or are the two digits here 9 and 0 divisible by 4, or is 90 divisible by 4? Obviously not. How about by 10? Obviously that's divisible by 10. How about by 12? For sure that's not. And for 8, that's also not divisible by 8. So the correct answer is letter B, 10. Let us now proceed to item number 3. I know that this one is very challenging to you. So the problem here says that around 420 players join in the volleyball tournament. Each team should have the same number of players. How many players could there be on a team? So there is no, from among the choices here, none could divide 420 evenly. So let us just skip that number and let's proceed to number 4. Now let's proceed to item number 4. David's little sister is playing with blocks. She wants to put all 63 of her blocks into stacks with the same number of blocks in each stack. So how many blocks could David's sister put into a stack? Okay, so the choices are 4, 6, 9, and 10. Remember that she has, or David's sister, little sister, has 63 blocks. Okay, so all we have to do is to determine if to which number is 63 divisible. For sure that's not divisible by 4. It's not also divisible by 6 because that's not even. It's not also divisible by 10, so the correct answer is letter C. For the last item, unluckily, there are no choices. So all you have to do is really to solve the problem. And the problem is, what is the biggest 3-digit multiples of 2 that you can think of that uses the digits 5 and 8? Show your answer using any method. So in this kind of problem, it says here biggest and 3 digits. 3 digits. It should be multiple of 2. Multiple of 2. So it should be even. Okay? Those are the given. And another one uses digits 5 and 8. So these are the digits that we could only use, 5 and 8. Remember that it should be biggest. So because it should be biggest and we will be using 5 and 8, so we will use 8 here. Okay? So to make it bigger, we could still use 8 here. And of course, 5 here. However, in this case, you should be a multiple of 2, so even. So we could not use 5 here. We could not use 5 here. Instead, we will just use 5 here. And of course, we will return 8 here. That's the biggest number that you could make. Let's check our answer. Multiple of 2. Yes, that's a multiple of 2. Uses 5 and 8. 8, 8, and 5. It should be the biggest. That's the biggest that we could make utilizing 8 and 5. So the correct answer is 858 for number 5. Did you get it right? Here's another problem that you will have to consider reflected in the page 9 of your module number 4 under the activity what I have learned. So that is in page 9 of your module. And the question here is, Nelly's father wanted to buy a new single motor, but he does not like numbers that are divisible by 3 or by 5. If all the single motor numbered between 100 and 150 are inclusive for sale, how many motor can be chosen from? So again, I will give you time to solve this problem, and later I will show you the solution for this problem. So this time you pause this video and answer the activity. Let us now see what's the answer for this problem and what's the best solution. So the problem is how many? The number of motor that can be chosen from. Remember, when we say 100 to 150 inclusive, therefore 100 and 150 are included because the word is inclusive. Okay, so another clue here, he doesn't like or does not like numbers divisible by 3 or by 5. So let us take all the numbers divisible by 3 or divisible by 5. So the choices are, numbers should be from 100 to 150. Okay, but we have to eliminate those divisible by 3. These are the numbers that are divisible by 3 from 100 to 150. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 numbers. Now, what are the numbers divisible by 5 from 100 to 150 inclusive? Here are the numbers which are divisible by 5 from 100 to 150. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers. So now, there are also numbers which appeared here in 3 and also could be seen also here in 5. And what are those numbers which is common to both groups? 105. Then we do have here 120. And of course, that's 135. And finally, that's 150. Therefore, these numbers 1, 2, 3, 4 were counted twice. It was counted here in 17 and was also counted here in 11. But the question only is or. So it simply means that if it is already counted with 3, that need not to be counted with 5, because these numbers are also counted in the other group. So the tendency is we have to add this, so that is 17 plus 11. So with a total of 28, then we will subtract 4 numbers which is counted twice. So that will just only give us 24 numbers which will not be counted from 100 to 150. But the next problem is, how many numbers are there from 100 to 150? Because we need to take away this 24, which he doesn't like to be the number of the motor that he wanted to buy. So all you have to do is just subtract 150, the biggest number, subtracted by 100, to be subtracted by 100 I mean, so that is 50, plus 1, so 51 numbers. Out of that 51 numbers from 100 to 150, then we will take away 24. So 51 minus 24. So this will become 11, so that is 7. This will become 4, so that is 2. Therefore, there are 27 numbers that he could choose from. Any question? The final answer is 27. Did you get it correctly? after all the activities that we answered and we shared together, I'm very much confident that you can now answer your assessment. So this time, I want you to take the challenge of answering your assessment that is on page 11 of your module number 4. Thank you so much for this very meaningful video lesson. Despite the fact that you are staying at home to be safe, you are still learning a lot. So I'm pretty sure that your parents are really proud of you, and I too is very proud of you. So to those who just watch and join me in this YouTube channel, I want you to click subscribe and at the same time click that bell button for you to be notified and to be updated of my video lesson. I hope that this one is really a helpful material for you. Thank you so much. I am your math video tutor, Sir Collin, saying goodbye and thank you so much.